So the object of the experiment number 1 is to determine the resistance of the given ferrialloy wire by Kelvin's double bridge method and find its resistivity. The Kelvin's double bridge method is a method employed for measuring low values resistance. And before looking into or observing this experiment, it is suggested that you go through the basics of what Kelvin's double bridge is, what are the categories of the divisions of low, high, medium and high resistances, and what are the methods which are employed for different ranges or categories of measurement of different categories of resistances. So shown over here is the circuit diagram. In fact, these are the two circuit diagrams which are shown in the which are drawn in the experiment sheets that have been provided to you. So on the bottom left side shows the elaborative circuit diagram for the purpose of analysis of the circuit, while on the right side shows the diagram used for the connection of the equipment while performing the practical. This is the experimental setup and shows the equipments that will be required for performing the experiment, and the name are given as follows. So this particular equipment is the ferrialloy wire or the unknown resistance given by X in the circuit diagram. This is the standard resistance or the known resistance given by S. This is the double arm ratio box. We have this has DP/DT or double pole double throw switch. This is the rheostat, and here is an ammeter. This is the DC power supply. This is the unknown resistance, the ferrialloy wire bridge, and these two terminals are the potential terminals, while these two terminals are the current terminals. And this is the known resistance. So it comprises of a series of studs as shown here. These are the studs, and this is the wire. These are the two potential terminals of the known resistance, while these are the two current terminals. So these studs as shown or highlighted here allows to change the resistance in at the first decimal place. So the first stud corresponds to a resistance of 0.1, the next is 0.2, third is 0.3, and so on. While then we have, so in fact this stud is a type of a coarse variation of resistance or a main variation in the resistance. Then we have a fine variation in resistance using this wire. So the marking are provided over this wire, and the variation in resistance that can be done using this particular. So it provides a fine variation in the resistance at the second decimal place, like 0.01, 0.02, 0.03, and so on. So this is the double ratio arm, and in fact this is the equipment that will be resembling the four arm resistance given in the circuit in the Kelvin's double bridge. And we have two terminals here and the two terminals here, and these are the middle terminals here are used for connecting the galvanometer. So it's written galvo here, divide by 1, then galvo divide by 10, and galvo divide by 100. So division by 1, 10 or 100 means that the reading the galvanometer will be showing will be divided by the corresponding value written there. While this is the power supply that is used for providing the required current and or voltages to the circuit. And let us look into the specification of this power supply of this device. So the front panel looks something like this, and then we have a current which can be varied to from 0 to zero point 0.5 ampere. So this can be seen to be written on the panel of this power supply. So and we have three variations in voltages, or we can obtain three different ranges of voltage at different terminals. So we have this particular terminal here written as 0 to 30 volt. Then we have here written as 0 to 5 volt. So the variation is written here as 0 to 5, 0 to 30. And then we have minus 15, 0 plus 15. So we can vary the voltage from minus 15 to plus 15 in the last three terminals. Then we have coarse variation and fine variation of the voltage values. So the display here, we have the display corresponding to current. This is the display corresponding to the voltage that the power supply will be giving. So this was about the power supply. Now we talk about the ammeter. So looking into the specification of the ammeter, this particular ammeter is capable of measuring from 0 to 100 milliamperes. And one thing that can also be observed by the non-linearity in the scale, that this type of ammeter is a moving iron type. Moreover, this can be looked into by seeing the symbol which is given at the display side of this ammeter. So it's a moving iron symbol, and thus this type of ammeter is a moving iron type of ammeter and will be used for measuring the current through the circuit. Now let us correlate the equipment and the circuit diagram given that we'll first try to identify the equipment using the uh, circuit diagram. So this is the unknown resistance. On the equipment side, we have unknown resistance here, and on the circuit diagram, it is shown here. Then we have the standard variable resistance, the double ratio box, the DP/dt, rheostat, power supply, and ammeter. And before moving any further about the practical, we will first try to figure out what is the double arm ratio box. So let us look what is inside this double arm ratio box. So as we can see from the top view of this ratio box, we have here written as gal watt divided by 1 divided by 10 divided by 100. Then we have terminal here as minus x, this is plus x, and this is A, this is terminal D, which is what mentioned in the circuit diagram of the given experiment, the manual. So if we try to figure out by unscrewing this, or making things inside out, we observe that under this panel we have a series of coils as shown here. So this terminal is D, which is this one. This is terminal A shown here, and then we have these terminals, and then plus X here and minus X here. And if we try to look what is and how the connections look like, so we draw these terminals and the corresponding resistances. We observe the connection as shown here. So, and then we saw that there is written divide by 1, divide by 10, divide by 100. So these are the terminals where the galvanometer will be connected. Divide by 1, and this is divide by 10 terminals, divide by 100 terminals. and the corresponding resistances are 25 ohm, this one again 25. These two resistors are 180, these two resistors are 908, while these two resistors are 1.11 kilo ohms. So if you try to correlate this with the circuit that is given to us for analysis purpose, so we see that the forearm of the bridge, that is capital M, small m, capital Q and Q, are the arms that will be resembling this connection. So this is the terminal A, which is given as here. This is D, this one, plus X is this one, and minus X is this one. So we can reform this in order to obtain this particular arrangement, and depending upon what option we provide for measuring using galvanometer, whether divide by 1, divide by 10, divide by 100 will change the resistance between the or the resistance Q, capital Q, M, capital M. So this is about the double arm ratio box. Now if we will be using this particular circuit on the top left side in order to perform connections. So we'll place the double arm ratio box here. Then we have a standard resistance placed here, the unknown here. Then we have DPDT and the power supply. Then we have rheostat and the ammeter here. We now perform the practical using the same setup. So shown here is the practical being performed on the left side, top left side, and on the top right side we can see the panels corresponding to the ammeter as well as the power supply, which is kept fixed. And on the top, on the bottom right side, we have the observation table being populated as we observe the readings. Notice that we are using multimeter in place of the galvanometer, and we will try to balance the bridge by varying the known resistance or the standard resistance, and we'll try to keep the reading in the multimeter as small as possible, since this particular multimeter is very accurate and has a high resolution. So it may be impossible for obtaining exactly zero on the multimeter because of certain small values that still exist in the circuit that the multimeter will be measuring because of its very low resolution. But nevertheless, we'll try to keep the readings in the multimeter as small as possible. So after obtaining these two readings for reverse and forward for 1:1, now we change the connections to 1:10, and we'll again try to balance it by varying the resistance in the standard resistance. So thus for forward we obtain the value of standard resistance is 1.331, and that becomes the value of the unknown as well. And now again in the reverse direction we obtain the same value, 1.331 ohms, which becomes the resistance of the unknown. Here you will have to prepare a report that must be accompanying the following questions. One is, why do low resistors have 4 terminals? The second is, why is the Kelvin's bridge method employed for measurement of low resistances? What are its advantages over the potentiometer type? Why is it necessary to take a second set of reading with the current in the circuit reversed? And finally, you'll have to draw a circuit diagram of the shunt used with the galvanometer.